Let's dig into the tangent constraint in Autodesk Inventor. Here on the screen I have a line that is floating out in space right now, and I have a circle that I have drawn at 1 inch. It is currently fully constrained. The line, however, can float. For a line to be tangent to a circle simply means that it is touching that circle at exactly 1 point. This line currently is not touching the circle at all. If I bring it down here, you see it is touching at 2 points, here and here. But if I apply a tangent constraint between the line and the circle, now I get it touching at exactly 1 point. I can drag that line all the way around that circle, and it will always be touching right on the edge. But this doesn't apply just to lines and circles. Let's draw another circle out here to the right. I can apply a tangent constraint to 2 circles as well. Those 2 circles will touch at exactly 1 point and only 1 point all the time. If I draw another circle out here, let's take a look at the other possible conditions. Here I have a circle that crosses the other circle at these 2 points. Here I have a circle that's not crossing the other circles at all. But when I apply a tangent constraint between any of them, now I have them touching each other at exactly 1 point. Let's clean those up and start again. Zoom back in on this original circle. Let's draw a circle this time inside our first circle. We can apply a tangent constraint to one circle inside another circle so that it is always stuck to that edge inside. It can be inside or it can be outside, and as long as it's touching at 1 point, it is still tangent. And generally speaking, when a constraint can apply to a circle, it can apply to an arc as well. Let's draw us an arc right here and draw a line out to the side. Let's let that be horizontal. That horizontal constraint symbol pops up there. But let's turn our constraint visibility off to clean this up a little bit. Now let's see what it looks like here at this joint between the two. We can see that break between the line and the arc that it touches. If I apply a tangent constraint between the two, now we see a smooth transition. Not mathematically smooth, that is actually the next constraint, and we'll dig into that in the next video. But we see a transition that does not have that definite break point between the line and the arc. Let's come down here to the other end of the arc. Let's draw another arc down here. Let's stick these 2 endpoints together with a coincident constraint, and now let's drag this around a little bit. There we can see that break point a little bit more definitely there, but I can apply a tangent constraint here as well, and we ease that transition, make a tangent transition from one arc to the other. So whether they are going opposite directions, let's add one down here. Let's use a 3-point arc, apply that. See, now they're both curving towards the inside. Add a tangent constraint there, and we see where we go from one radius to another. We have the tangent condition between those 2 arcs. Now let's clean this up and look at one more condition where we can use the tangent constraint. Let's draw a circle back up here. Again, this could be an arc. Let's put a dimension on this so that it does not move. We'll leave it at 3 inches. And now I'm going to draw a line out here. I'm going to make it be horizontal. Let that horizontal constraint pop up as I draw it, so it will be fixed in that horizontal orientation. And now I'm going to apply a tangent constraint between the line and the circle. See, that line now jumps into place, though it does not actually touch that circle, because if I were to drag it out here to the left, now I would have it touching at exactly 1 point. So it can kind of works by extension. It doesn't have to be touching directly, but if I were to extend that line out, then it would be touching at exactly 1 point. One last thing to mention before I move on and show a few more concrete examples on a solid model is that the tangent constraint does apply to splines as well. Let's draw a line right there and then come down here, zoom in on this end and draw a spline. We can apply a tangent constraint as well between a line and a spline to straighten out that transition. But we will dig deeper into splines in the next video when we look at the G2 curvature, the smooth constraint that applies only to splines and does not apply to arcs and circles. So now I have deleted all of that, and let's take a look at a few more concrete examples of some things we can do with the tangent constraint. Let's just create a quick block up here, and we'll start drawing on this. Of course, anything that we're doing here, we could be creating new solid geometry, or we could be cutting away existing solid geometry. But for these examples, we're going to sketch on this block and make some modifications to it. Let's go down here below the rectangle tool and look at the slot, center to center slot. We'll use that one. And let's just draw a slot up here. And we saw briefly before I finished, we'll turn constraint visibility back on. We can see when we draw a slot that it gives us 4 tangent constraints, that it puts these lines tangent to these arcs. If I wanted to draw my own slot, let's say I came up here and drew, this is going to be a little bit sloppy on purpose, as we do sometimes to demonstrate these. Draw 2 arcs up here. Click on the endpoints of each of those arcs to create these 2 new lines. And then I can apply a tangent constraint between arc and line, that arc and that line, that arc and that line. See, I got a little bit of this arc sticking out here. I could trim that off, or I can use a coincident constraint to stick that down. See, I did get a horizontal constraint on my top line. Let's apply a horizontal constraint to the bottom line. And there we have a slot that we drew ourselves. But since Inventor has the slot command and draws slots for you so nicely, if all you need is a slot, use the slot command. It seems to handle that just fine. But let's get rid of all that and draw something a little different. Suppose we need a cutout through this block, and our 2 ends, our 2 arcs on the ends are not the same diameter. Let's draw a couple of circles up here and draw a couple of lines between them. Sometimes it will, if you get in the right spot, you can get that tangent constraint automatically applied. We'll leave that one on there. So we've got one to start with, but then we can apply our tangent constraint to the rest of these points where the line touches the arc. Now I can apply whatever dimension I want to this. Let's make this 1 inch, where the other end is a 1/2 inch. Let's put these 2 center points horizontal from each other. Let's make them horizontal relative to the origin point as well. If you missed that use of the horizontal and vertical constraints, that's in previous video. If you get back to the playlist, you can find that one. But let's apply a few more dimensions to get this sketch fully constrained. And we can trim the insides of these arcs so that now we just have that outline. I can use this, can finish that, and extrude that cut all the way through the block to get that shape cut out. Let's do one more demonstration here. Let's create a sketch on the end of this part, and maybe I want to apply a special edge treatment, cut down this edge of this part. Let's back up and get out of this sketch. Let's cancel that sketch. If all I want to do, let's do a fillet on this corner. If all you want is a fillet, you click on the fillet command, and that rounds that corner for you. And certainly we could come in here and draw that. Let's use a 3-point arc. I want it to touch that line, curve that way. Tangent constraint there, tangent constraint there. Put a dimension on it, finish that sketch. Then I can extrude and cut that tangent, or cut that fillet rather, all the way down that part. And of course I could use the fillet command to do that, but if I wanted something a little more complex, let's delete that sketch, that feature, and add a new one here. Suppose I wanted something that looks like this. Maybe I've got an angle that then blends into an arc. Now I can apply a tangent between that arc and that edge, tangent from that arc to that line, add some dimensions up here. And now I can take that profile, finish that sketch, and extrude that cut all the way along the edge of the part to get something with a little more advanced geometry than a standard fillet. Let's do one more quick demonstration on this part. I'm going to create another sketch on the face of this part this time. And let's remember what we said, where that a line doesn't have to actually be touching an arc or a circle to be considered tangent to it. Let's say I want to use this edge of this cutout and this vertical line here on the bottom. I can make this vertical line tangent to that arc on that cutout, and that will always match then. Let's throw some more dimensions up here. That will always match the length of this bottom cutout that I'm going to make to the edge position of that arc. I see I need a coincident constraint down here to get that line onto the edge of the block. And now if I finish this sketch, extrude this cut, it goes all the way through. Now just to demonstrate quickly why this can be a benefit and why constraints in a sketch are so useful, let's go back in and change now this dimension. Make that arc smaller, which moves that edge of that arc further from the edge of the block. And when I finish that sketch, see that edge of our bottom rectangular cutout updated with it automatically as well. And that's what we're looking for. Using constraints wisely gives us that kind of control over the part. If I know I want this always to match the position of the edge of that cutout, then using those constraints will help us make things update automatically. I hope this information has been useful to you. If it has, it would be greatly appreciated if you would give this video a thumbs up. That helps this channel grow. If you're not already subscribed to the channel, consider subscribing as well to get more videos. If you are ready to move on to the next video, in which we will discuss the smooth constraint that we can apply to splines, as we discussed earlier, here is the link for that. If you would like to get back to the playlist, here is that link as well. Thanks for watching. Have a great day.